This Bari here. So on Friday we're gonna have a test, and right now I'm gonna go over test number 11 from problem 1 to problem number 14. Please review all of the problem, especially problem 8 is very important, the Josh problem. Right? You have many steps in problem number 8, and problem 1 also make sure you understand problem 1. And tomorrow is the Einstein competition, and part of the Einstein competition going to be based on Black History Month. I created a website to celebrate, to showcase the contribution made by Black scientists, right? And this is a fitting way of celebrating the Black History Month, is because Einstein himself used to share ideas, math and physics ideas, with the Black scientists in his time. So make sure you understand the physics part of tomorrow's Einstein competition, which is going to be based on this tutorial, and of course on the Black History Month aspect of the Einstein competition, which is, I already posted the website on the Google Classroom. All right, let's dive into solve the problem number 1. Say I have a spring and I have 5 kilogram mass, okay, at equilibrium. What does that mean? F is 0. What does that mean? Kinetic energy is maximum. What does that mean? Potential energy due to spring is 0. We're going to call location A. Now you stress it. Potential energy is no longer 0. Why? You stress it 0.05 meters. The K is, let's say, 400. And let's say there is a friction. Okay. What we need to find is, oh, by the way, kinetic energy is 0 over here. Why is that? Because you let it go, so it's going to go back and forth. What is the Fs? Fs is negative kx over here. Why is that? Because this wants to go back to where? Equilibrium. Okay. So this is location 2. I want to say location 2 is right here. Okay. So now kinetic energy over here at location 1 is equal to potential energy at location 2 now. Why is that? Because, of course, there is a friction. So we have to write, we have to subtract the friction. So what is potential energy? Potential energy is half kx squared. So potential energy is half 400.05 squared. So potential energy is 0.5. Now we want to find the kinetic energy. Now, work done by friction. Work done by friction is FFD. What is FF? Mu K mg d. Okay, so mu K is 0.15, m is 5, g is 9.8, d is 0.05. You can put negative over here, 1, because this is cosine 180. Not going to make any changes. 0.37. Okay, so what we get? Kinetic energy is 0.5. You can say 0.5 if there is no friction, but there is a friction. And how much that will lower the kinetic energy. So kinetic energy is no longer 0.5. It is in fact 0.13. Okay, if I ask you what is the kinetic energy, 0.13. If I ask you what is the velocity, then that's a different story. Kinetic energy is 0.13. Half mv squared is 0.13. mv squared is 0.26. So velocity is 0.26 divided by m, which is 5 square root. So yeah, velocity is something. Okay, whatever it is. Quickly go over problem 2. Problem 2, what happened? A ball is coming with 30 meters per second to the bat. So there is a bat. This is problem 2. A ball is coming to the bat. A ball is coming to the bat with 30 meter per second, right? This ball is coming to the bat with 30 meter per second. And the bat hit the ball with also 30 meter per second. And the ball is moving now this direction. Okay. So the ball is 1 kilogram. Is that right? The ball is 1 kilogram. Yeah. Ball is 1 kilogram. So what is the momentum initial? Momentum initial is mass times velocity. So 30 kilogram meter per second. Momentum final, negative 30 kilogram meter per second, right? Okay, so what is the change in momentum? Momentum final minus momentum initial. Momentum final is negative 30, momentum initial is 30, so it's negative 60. I ask you to find the average force. Now, what is average force? You know that change in momentum, which is impulse, is equal to the impulse. So this is impulse, this is impulse, this is impulse. You can say that. All right, so these two will serve our purpose. So delta P is equal to F delta T. We want to find the average force, delta P over delta T. Okay, if the collision between ball and bat happens just, let's say, 6 millisecond, then that would be, what is it, 60 divided by 0.0006. So 60 divided by 0.0006 would be what? 60 divided by 0.0006, and that would be 100,000. So 100,000 Newton. 100,000 Newton. Okay, so that was the problem. Now let's go over problem 3. Problem 3 is supposed to be very easy. It's a momentum problem. You have M1, which is 1 kilogram, moves with, let's see, M1 is 1 kilogram, moves with moves at 2 meter per second. M2 is 2 kilogram, moves with 1.5 meter per second. This is before. After the collision, M1 is moving with 1 meter per second. What about M2? So we are trying to find V2. It's a very easy. Momentum before is equal to momentum after. M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2. M1 is 1 times 2 plus 2 times 1.5, 1 times 1 plus M2 is 2 times V2. So you have 2 plus 3 minus 1 plus 2 V2. Okay, so what do you have over here is 4 is equal to 2 V2. So V2 is 2. So this one is moving with 2 meter per second. Okay, let's go over problem number 3, or I rather problem 4, right? Yeah, problem 4, Josh. So recoil velocity of that. So Josh is, let's say, 60 kilogram. I'm using one of the set. The jump height is 0.8. Crouch height is 0.2. Okay. Location 1, Josh is equal to R. That's location 1. Location 2, he is crouching from 1 to 2. Location 3, location 4. The Earth moving to location 4, Josh moving to location 3. What does that mean? You have to find the velocity of who? Velocity of Josh. So, because remember, M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2. Before Josh jump, his velocity is 0. Before Josh jumps, Earth velocity is 0. So 0 plus 0. We need Josh mass, which is 60. We need Josh velocity. Let's find it. Vf square is equal to Vi square plus 280. At location 3, from location 2, location 3 is 0, location 2 we are trying to find it, 2 times negative 10 d. So d is 4. So d is 0.8. Where is 0.8 come from? Over there. So 0.8. So then velocity is 4. Velocity is 4. Now m2 is, we already know, 6 times 10 raised to 6 times 10 raised to 24. Velocity 2. Recoil velocity 2. Oh wow, we found it. Very nice. It's easy. Okay, so 240. So velocity 2 is 240 divided by 6 times 10 raised to negative 24. So that 40 times 10 raised to negative 24. So it's 4 times 10 raised to negative 23 meter per second. The velocity of the recoil. Let's say I give you an inclined plane and I put location B at the d distance away from location A, and I put a mass at location B. Let's say there is no friction. In the next problem, I'm going to bring friction, making it a little bit more difficult. Okay, so how much work done? So this is height h above the ground. My simple question is how much work done on the mass, which is height h above the ground. What does that mean? How much work done on the mass as is sliding from location B to location A. Okay, how much work done by gravity? How much work done by gravity as is sliding from location A to B, assuming that there is no friction? Okay, 10 seconds away of solving the problem is mgh. M is 100, G is 9.8, H is 30. So this is 29400 Joule. If I use the 10, that would be what? If this one is 10, that would be 3, 1, 2, 3, 4. That would be 30,000. Okay, both of them right. Let's say that one is better. Okay, now another way of solving this problem, work done by gravity. Okay, FG parallel is what? Acceleration is g sine theta. Okay, so F is equal to ma. So F is equal to m is g sine theta, or you can do F, only one component of the gravity does work on the mass. This one doesn't do any work. This one does zero work on the mass. Only this one does. So mg sine theta. So work done by gravity on the man is Fg parallel times d. Fg parallel is how much? Mg sine theta. And d is what? This is 30. So Kartova. Sine theta is equal to opposite, which is h. Hypotenuse, which is d. D is h over sine theta. So mg h over sine theta. Mg, okay, d. Oh, I should write over here. H over sine theta. Sine theta cancel, so mgh. So same thing. So work done by gravity is 29,400, as you say, as you see over here. Okay, so great. Now I gave you granite. Granite is 30 kilogram, and granite is moving 40 meter per second. That direction. So what is the momentum before? 1200 gram meter per second. Now, what happened after? The one piece, well, you throw it in the air, okay, the 30 kilogram granite, and it broke in two pieces. One piece is 15 kilogram, moves to the west, move to 180 degree, 10 meter per second. Other one moves northeast. If this one 15, this one has to be 15. We want to find the angle of the resultant. Okay, one thing we know that momentum before is equal to momentum after at x direction. Momentum before is equal to momentum after at y directions. At that, this is y direction. Momentum before at the x direction is 0. So this must be 0. m1 v1x plus m2 v2x. m1 is how much? 15 minus 10. So v2x is 10. This is 1200. m1 v2y plus m2 v2y. This is 0. So 1200, 15 v2y. So v2y is 80. Okay. So now resultant is 10 square plus 80 square. So resultant is 81. Theta is tangent inverse 8. So theta is 83. So the granite is moving what direction? 83 direction, 83 degree, 81 meter per second. So this one is moving, of course, 10 meter per second at 180 degree. This one is moving 81 meter per second at 83 degree. In both cases, when we say degree, we mean with respect to x. Now, let's start with this conversation, okay? And you have to decode the color, okay? So please make sure that you pay attention, okay? I'm using color carefully, so you should be able to decode the color. Okay, pause the video for a few seconds and now write down 4 equations. Make sure that you keep in mind I asked you to decode the color. All right, hopefully you try. Now let's try together. Now let's use the blue color, of course, mg, and of course mu k mg. You can also write mu s. That's not important here. Okay, now the other one, of course, the Newton's second law, F equal ma, and this is ma. What does that mean? That means is ff is mu k mg is equal to ma. What does that mean? Okay, and that give you a big discovery. Mu k is equal to a over g, right? Why is that? Because as you see that a is equal to g mu k, so mu is equal to a over g. All right, very nice. Okay, so now the classical mechanics review part 1, we're going to go over a few problems. Let's see this one in action. Okay, how can we see this one in action? Very simple. Let's say you have an object. Let's say you have a surface. And you place a ball with mass m and velocity, let's say initial velocity 10 meter per second. The ball keep rolling, 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 rolling for a long time. And then finally, at location B, the ball comes to stop. What causes the ball coming to a stop? Wall friction, right? Friction slowing down the ball, and ball come to a stop 130 meter away from location A. Good. You know that kinetic energy over here is 0. Kinetic energy over here is half mv square. And I don't see any other energy over here, potential energy or any other energy. So how can we solve this problem? Well, okay. There are two ways of solving this problem. Let's do fast one. First one, let's say Vf squared is equal to Vi squared plus 280. Vf is 0, of course. Vi is 100. Why? 10 squared is 100 times A times D. D is 130. So acceleration is negative 100 over 260. So acceleration is negative 0.38. Step number 2 would be what? To write Wf is equal to write Ff is equal to what? Mu k mg. And Ff is Ma is equal to mu k mg. Cancel. Mu k is A over g. Mu k is A is negative 0.38, negative 9.8, 0.039. Okay, we're gonna do it differently. What that way be? Let's say we're gonna write work done by friction is equal to change in kinetic energy. So work done by friction is equal to kinetic energy final minus kinetic energy initial. You see that kinetic energy final is 0. So work done by friction, which is of course FFD, is equal to half mv square negative. FF is mu k mg d is equal to negative half mv square. Cancel. Okay, now you have 2 mu k gd is equal to v square. So now mu k is negative v square over 2gd. So mu k is negative 100 to negative 9.8, 130. So mu k is 0.039. Both way you get the same answer. Not sure which way make that easy to solve the problem. Okay, and that is the most important problem. Problem number 8, you have at location 1 you have 2 people, Art and Josh. At location 1. At location 2, Josh crouching between location 1 and 2. Location 3, Josh. Location 4, Art. Josh is moving to location 3, Art is moving to location 4. Let's put them in table. Art. Let's study Josh. Art. Location 1, 2, 3. Velocity, acceleration, time. Let's use the different color for Art. Location 1 and 4. Velocity, acceleration, time. Okay, good. At location 1, what is the velocity of Josh? Location 1, this is location 1, velocity is 0, acceleration is 0, time is 0. What about Art? At location 1, the velocity of the Art is 0, acceleration of the Art is 0, time is 0. Okay, so we kind of finish half of the problem. Now, at location 2, what happened? He crouches between location 1 to 2. So we want to find the velocity. Vf squared is equal to Vi squared plus 280. So V location 3 square, V location 2 square plus 280. So 0 is equal to what? Negative 10d. So velocity at location 2 is 4. Let's see whether we can find acceleration at location 2. Vf squared is equal to Vi squared plus 280. We are trying to find the velocity at location what? 2 by using the velocity at location 1. So location 2 is square, location 1 is square plus 280. Location 2 square is 4 square is equal to location 1 square is 0 square plus 2 acceleration we try to find, he crouch. So Josh jump height is 0.8, Josh crouch height is 0.2. So acceleration is 40. Let's see if we can find time. Vf is equal to Vi plus 80. All right. So the Vf, we're gonna use the we want to find the time at location 2. Okay. So location 2 is equal to location 1 plus 80. Location 2 is his velocity is 4. Location 1's velocity is 0 plus 40t. 4 divided by 40 is 0.1. Which is kind of instantaneously. 0.1 doesn't really, nothing. Velocity at location 3 is 0. Why is that? Because it's turnaround. Velocity at location, acceleration at location 3 is because he's in free fall, negative 10. And time, location 3. Vf is equal to Vi plus 80. The time between location 3, 2 and 3. So location 3 is equal to location 2 plus 80. Location 3 velocity is 0. Location 2 velocity is what? Velocity is 4. And then of course negative 10t. So t is equal to 0.4. So 0.4. Okay, now we want to find the velocity of the earth. Now he moves to this direction, as I said, and earth moves to direction. So what is the recoil velocity of earth at location 4? Okay, so momentum before is equal to momentum after. So m1 v1 plus m2 v2 is equal to m1 v1 plus m2 v2. Fine, of course. This is 0, this is 0. M1 is, he is 60, Josh is 60 kilogram. And the velocity is 4. Plus M2 is 6 times 10 raised to 24. That's the earth. So velocity of the earth is very simple. 240. 6 times 10 raised to 24. So velocity of the earth is 4 times 10 raised to negative 23. Velocity of the earth is 4 times 10 raised to negative 23. The acceleration of the earth is also same. The earth accelerates as long as Josh accelerates, because when Josh is in the air, earth doesn't accelerate anymore. Okay. Acceleration of the earth. Vf is equal to Vi plus 80. Vf is equal to V4 is equal to Vi is V1 plus 80. V4 is equal to 4 times 10 raised to negative 23. This is 0 plus A is and the acceleration. That's what we are trying to find, 0.1. So acceleration is 4 divided by 0.1 times 10 raised to negative 23. So you have 40 times 10 raised to negative 23. So 4 times 10 raised to negative 22. Okay, good. Now let's see whether we can get the answer same. F is equal to ma for earth for Josh. F is equal to ma for earth. For Josh, m is 60, the acceleration is 40, so 240. 2400, the net. Equal to m is 6 times 10 raised to 24 times acceleration is 4 times 10 raised to negative 22. So times 10 raised to 2. So the force on earth is 2400. Okay, so these are the net force. One is this direction, one is this direction. Let's see whether we can confirm that. We see that F Josh is equal to F Earth. The magnitude are the same, 24 Newton. We can call it net force. Let's see whether that's true. This is Josh, this is Earth, this is Earth and Josh. So this is Newton second law, this is Newton third law. This is mg, so 60 times 10, 600 Newton. This is fg, f prime g, so this is g m1 m2 over r squared. If you do that, it's going to get you 600 Newton. This is f push is equal to mg plus a, so 60 times 50 is 3000. If this is 3000, this should be f push prime is 3000. Okay, so what is the net? 3000 minus 600 is 2400. Check. 3000 plus 600 is 2400. Check. Now let's put them together. FG prime, both equal and equal in magnitude, opposite in direction. F push, or we can say F on Earth by Josh, F on Josh by Earth prime. Now this one, plus this one is 2400. This one plus this one is negative 2400. Now let's say you have a x-axis and a y-axis. This is problem number 9. I want you to draw the vector. This is x and this is y. I want you to draw a vector A. Vector A is above the x-axis, which is 7. This is vector A. Vector B is like 100 degree above the x-axis. This is vector B, is also 7. Vector B. Now let's make a parallelogram. I have how many angles? I have 1, 2, 3, and 4. Angle 1, angle 2, angle 3, and angle 4 must be 360. Now let's measure angle 1. Okay, if we know angle 1, we know all angle 54. So angle B has to be 126, angle 3 has to be 54, and angle D has to be angle 4 has to be 126. Now you can solve this problem two different ways. R squared is equal to A squared plus B squared plus 2AB cosine theta, and R squared is equal to A squared plus B squared minus 2AB cosine theta. This is law of cosine. This is law of parallelogram. Law of parallelogram use the angle between two vectors. Law of cosine use head and tail. Okay, if that is so, then let's see. R squared is equal to 7 squared plus 7 squared plus 2, 7, 7 cosine. Angle between two vectors is this one. Angle between two vectors. And this one is 54. And that gives you 13. R squared is equal to 7 squared plus 7 squared minus 2, 7, 7 cosine. Angle between head and tail, this is head and this is tail. Angle between head and tail is 126. So that's give you 13. Okay. So make sure that you don't use head and tail over here. If you do use 126, it's gonna give you wrong answer. Some reaction time is important, especially if you drive, right? And someone crossing the road. Whether you would be able to save the life depending on your reaction time. One way we can measure the reaction time by dropping a ruler and allowing you to catch the ruler. For example, my left hand going to drop the ruler and my right hand going to catch it, or at least try to do that. Now, if I read it is 30 centimeter. Now, this 30 centimeter, okay, will allow me to find my reaction time and check if I am ever a driver driving the road, and if someone ever cross the road, I have to hit the brake, would I be able to save the life? Okay, let's dive into the problem and let's see what I'm talking about. First, find the reaction time with the activity that I just shown you. The reaction time would be d is equal to VIT plus half AT square, right? And this is 0, d is negative 0.30 because 30 centimeter is negative 5t square. Why is that? Because d is equal to negative 10. So t is equal to 0.24. Okay, that's the reaction time. How this reaction time will say whether I'm a good driver or bad driver, whether I would be able to save anybody's life if I'm on the road driving. I'm on the road driving. At location A, I see a man crossing the road at location C. Okay. What I know about location A, D is 0, T is 0, acceleration is 0. I'm driving at 40 meters per second. Okay, good. Now, at location B, when did I hit the brake? Did I hit the brake at location A? No, I hit the brake at location B. What time I hit the brake? 0.24. So it took more than 0 seconds for me to uh, realize that someone is crossing the road and I hit the brake. Okay, so we can find the d over here and we can do the other thing. And velocity is still 40 and acceleration is negative 80. Okay. All right. Now, at location D, what happened? At location D, my car velocity is 0. Now, understand this. If C is equal to D, then outcome is something like this. If D is greater than C, then outcome is very bad. If D is less than C, then outcome is very good. Okay. What does that mean? Distance, let's find distance. A to B, B to C, C to D, A to C, and A to D. We already know uh, A to C. A to C is 60 meters. The person is moving 60 meters away where I first see the person, right? Okay, good. Now let's find the distance. Now, whose outcome? Outcome 1, 2, or 3? Well, desired outcome is 3. Does that mean we'll accomplish that outcome? Well, probably not. Why is that? Is the reaction time is very big? No, not because that. It's because the velocity, initial velocity is very big, 40 meters per second. That's like just too much for the car to stop within 60 meters. Okay, so let's find the velocity. Velocity between A to B. This is location B. Okay, so d is equal to VAT plus half AT squared. Acceleration 0 because he did not hit the brake yet. So d is equal to 40 times 0.24. So d is equal to 10. So A to B, the velocity, the distance is 10. Therefore, we know B to C is 50 because 60 minus 10 is 50. Okay, now B to D, VF squared is equal to VI squared plus 2AD. This is VD squared plus this is equal to VB squared plus 2AD. 0 is equal to 40 squared plus 2 minus 8 and D. So D is equal to 1600 over 16. So D is equal to 100. So B to D is 100. So B to D So B to D is 100. C to D is 50. A to D is 110. In the question, I ask you to give me A to D, 110. You wanted to stop the car before 60 meters, but you ended up stop the car at 110 meters. Whose outcome? That gives you this outcome. Not a good outcome, not a desirable outcome, but it is what it is. Okay. And you try to move it 45 Newton at 30 degree. There is a there is a friction, and that mu k is 0.2, and it moves how long? 3 meters. What we are trying to find is how much work done by friction. Okay, how much work done by friction. To find that, let's find both component. So this is 45 cosine 30 and 45 sine 30. I believe this is 34, 39, this is 23. Okay, so let's see the free body diagram. FAX is 39, FAY is 23, FG is 100, FN is 100 minus 23, 100 minus 20 is 80, so 77. So FF is 77 times 0.2, so FF is mu k Fn, FF is 15. Okay, so now is FFD. FF is how much? 15, and D is 3, so 45. I give you DT graph. The object move 1, 2, 3, 4, 5 seconds. 0 to 2 second object move 4 seconds. 4 meters. 2 to 3 object at rest. 3 to 4 object move additional 4 meters with acceleration. 4 to 5 object move the distance of 4 meters with deceleration. Okay, so that's it. Now you're going to do VT graph. 0 to 2 second, the velocity is 4 divided by 2, 2. 2 to 3 second velocity is 0. Let's use the different color. At 3 second velocity is something. At 4 second velocity is 0. At 5 second velocity is something. You connect these two dots. Let's find the area. Area is half BH. And area is distance. Distance between 3 to 4 is 8 minus 4. Time between 4 to 3 is 1 second. Velocity is 8. Okay. So at this is 2, this is 3, this is 4, this is 5. At 3 second velocity is 8. At 5 second velocity is negative 8. So the slope of this one is must be then negative 8 by y2 minus y1, x2 minus x1. Then y is equal to mx plus b. If you put 8 over here, and if you put slope over here, and if you put 3 over here, then you get y-intercept, which we call the initial velocity, 32. Then you get y is equal to mx plus b, which is vf is equal to vi plus at, which is v of t is equal to at plus vi, which is v of t is equal to negative 8t plus 32. You can always check whether this equation is right by plugging in 4 y at 4, you know the velocity, 0. This equation actually gives you 0 at 4 seconds. That's how you know the equation is right. Now, in the problem I ask you 4.1. So 4.1, you know velocity is very close to 0, negative 0.8. I ask you the power. So the power is W over T. So power is Fd over T. So the power is Fv. So power is MAV. So the power is 10, negative 8, and V is negative 8. So power is 64 watts. The mass of the object is 10 kilogram. And that was that problem. Problem 13. We move north. You move north how much? You move north 10 meter. So you move 10 meter at 90 degree. And then this is your x-axis. So uh, you move 30 meter 20 degree. You move 30 meter 20 degree. So let's do a parallelogram. So if this is 20, this is of course 70, and this is 70. This is of course then 110, and then 110. So yeah, so 70, 70, 140, 110, 110. We're gonna give you 0, 5, 6, and 360. Good. Now this is called angle between two vectors. If you use that, then it has to be a squared plus b squared plus 2ab cosine theta. So r squared is equal to 10 squared plus 30 squared plus 2 times 10 30 cosine 110. Because that's angle between two vectors. Now let's find out what is that gonna give you. So you have 10 squared. This is like 10-second problem. All you need to do learn how to do plug in. 2 times 10 times 30 cosine 110, and that gives you 28. So r is 28. Okay, 28 meter. This is 12 kilogram, right? And then this is fa, and this is accelerating 3 meter per second to the left, to the right, and this is ff is 10 newton. And this moves for how long? It moves for 2 meter. What we are trying to find, what is the magnitude of work done by friction, by net force. Okay, so two ways you can do it. One way is try to find fa. So you have delta f, sigma f is ma. So you have fa, okay, minus ff is equal to m is 12 times 2. So fa is 34. Okay, that's good. What is net force? Net is fa minus ff. So 34 minus 10, 24. Work done by net is F net D.